So it's video season, and I thought I'd better make a new video for by Friday, along with everybody else. So this is a job I was called out to. I haven't installed this, but it's a very interesting job, very much in line with some of the teaching that was going on at the weekend. So it's an Aventa. The manufacturer's engineer came out, told them that the heat exchanger was no good and was blocked, and I was asked to come and have a look at it. What I found was that the flow and return were actually plumbed in backwards, and that's right, it's just drying, it's not covering a leak, and plumbed in backwards, so the boiler wouldn't run. It was giving very good symptoms of a blocked heat exchanger. The guy that had installed it, I changed the pump round the other way to make the pump run on the flow. It's all been modified now, by the way. And it still gave really good symptoms of a blocked system. So the manufacturer had sent free of charge a new heat exchanger, a new cementer heat exchanger, as he thought it was blocked. It's sitting out here in the garbage somewhere. I'm not sure where. It's there somewhere. Anyway, even with the pump turned around, still gave symptoms of a blocked heat exchanger. It was getting really bad delta T. So as the heat exchanger was here, pulled out the old heat exchanger, popped this new one in. Very, very easy boiler to work on, the Aventa, by the way. I think even easier than the Residual 100. Really, really surprised at how easy it was. And popped the new heat exchanger in, put the boiler back up, flushed through, blah 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 blah. Still got the symptoms of poor flow. So I thought I would actually carry out the theory. When I'm teaching it, I'm always saying that we don't really actually ever do it, but it's useful for diagnostics. So I thought, well, why not? Let's give it a go. So I thought, well, let's find the chart for the boiler. So I did. This is the resistance chart for the boiler, and showing resistance on this number 2 is for the 24, so it's the 18. Resistance on the 18, that one there. Worked out my mass flow rate, and the calculation is here. So they're saying they want delta T 11. I've actually used 10. It's come up with a flow rate of 0.42 meters a second, litres per second. Converted that to cubic meters to 1.5. So at full output, I need 4.5 meters of head, and just to overcome the resistance in my heat exchanger on the boiler. And it's fitted with a 1550 pump, which means I've got a residual pump head of 0.5 meters. What chance have I got of getting the system to work on 0.5 meters? I can't even get to run through this solar cylinder, which I didn't do this again, as I say, but the guy was instructed to do in series and not in parallel. So he's not only got the resistance of the first coil, but got the resistance of a second coil, and there's just no way that this pump can cope with that. So the cure for this, either a bigger pump, which I think would have to be a 7 or 8 meter head pump, which is crazy on an 18 kilowatt boiler. Imagine coming in and seeing a sort of 7 or 8 meter head pump would seem ridiculous, but that actually is what's needed. So what we're going to do is hydraulic separation. I'm going to pop in a close cup of tea, and we'll stick in a second pump here. And this 5 meter head pump should be more than adequate to do the system, and one 5 meter head pump will be enough to do that boiler. The crazy thing is that the boiler requires more pump head than the whole system does. So not a good advertisement for a cementer heat exchanger, I must say. Although the Residual ones still have quite a high resistance in them also. But anyway, if I didn't know the theory, I would have struggled with this one. I would never have thought the pump wasn't big enough. I might have tried a 1560 pump, but I would never have got the graphs out, never worked it out, and never realised that it was wrong. And in fact, I'm kicking myself now, because if I'd actually done it properly in the right order, it would have saved me a lot of time on this job as it is.